Hi, everyone. Welcome. You're in the right spot. We're going to talk about some really cool stuff tonight. And bonus, it's clear out. So it's been a cloudy few weeks, but we actually got some telescopes up on our observation deck. So it's going to be a fun night tonight. We're going to wait just another moment or so to let people come in or continue to come in. We will be using the the question and answer box tonight for any questions you have from us. We'll have a few links to share out with you this evening in the chat box as well. That'll be links to our star map and a fun at-home activity as well. But that's the only thing we'll use the chat box for tonight. We do want you to use the Q&A box. We love answering your questions. It's the best part of my day, I think. And so we'll get to as many of those as we possibly can throughout our hour together. So welcome. Got lots of people coming in. That's so exciting to see all of you. So before we go any further, I do want to say that that as a museum here at the Bell, that we aim to advance our collective understanding of both the Earth and the sky. And I would like to take this time to acknowledge the Bell Museum sits on traditional and treaty land of the Dakota people. And I would also like to acknowledge the Ojibwe people, the traditional keepers of lands to the north. That Dakota and Ojibwe knowledge systems are crucial ways of knowing this place we now call Minnesota, and that we here at the Bell honor that knowledge, the values embedded in it, and the people who keep it. So like I said, my favorite part of the night is question and answers. So please use the Q&A box for getting all those questions to us, and we'll respond to as many of them as we can. Hopefully we'll get to all of them tonight. We have a whole team behind the scenes here. It's myself and Tad's up on the roof with our telescopes, but we have a whole bunch of other people behind the scenes to make sure everything runs smoothly as well. We also have live captioning tonight. And if you find those captionings useful, you can go ahead and turn them on. They're at the bottom of your screen. But if you do want to hide them for any reason, you can go ahead and hide them using the live CC button on the bottom of your screen as well. Okay, but before we go into what's up tonight and go check in on Tad, I do want to say, did anybody get to see the great conjunction of Jupiter and Saturn last month? Now, I hope you did, because it was really cool. We were all hoping and getting geared up for it because it was going to happen on a Monday, and it was cloudy here on a Monday. However, there was a little brief moment of clear sky on Tuesday night around like 5:30. So I dashed outside real quick and just took my cell phone camera. And this is what I was able to see from where I was. And so I hope many of you got to see this as well here. Oh, there we go. And so from the ground, it looked like this picture on the left. We saw just that little bright point right there. That is what I saw just viewing my eyes. And this picture, I do not think it does it justice. Again, it was just my cell phone camera between very quick breaks in the clouds. But I was able to get one of our non-tracking telescopes up really quickly out. So not one of the ones that we're used tonight. But on the right side of the picture here, this is what I saw through our telescope, again, using my cell phone camera. So that brightish one up here, kind of more in the center of the screen, that is Jupiter. And down to the lower left, is actually Saturn. You can kind of see its oblong shape there that the shape the rings create. And one of the great things, again, even using my cell phone camera, which is a cell phone that's years old, we not only captured Jupiter and Saturn, but faint little tiny dots off to the side of Jupiter there that I can see a little better when I lighten my image. I was actually able to capture Europa, Callista, and Io as well, 3 of Jupiter's Galilean moons. So this is just a really cool thing that happened last month, and I hope you guys got to see it outside. Jupiter and Saturn will return to our skies later this year. Right now, they're kind of hiding behind the sun. So we have to wait a few more months before they come back into view in our night skies. Okay, but we're going to look out tonight. Tonight is the first clear night we've had in probably a few weeks here in Minnesota. And so we have our star map here on screen, and we'll put a link to our star map in the chat for any of you who want to go ahead on our website and download that. Go ahead and do that. But what we do here is this is how you read it. This star map has a round edge, and you might wonder why it's round. Well, that's our horizon. And so if we were to stand in one spot and just do a quick circle around looking at the all directions from where we are. That's the outer circle of our map. Here is the horizon. Now, if you're outside and you look directly above you, that's when we get to see what's called the zenith. And that's going to be the point at the very center of our map right here. So when we look for things out in the sky tonight, the closer they are to the edge of our map, the closer to the horizon they'll be, the closer to the center of our map, the closer to straight above us they will be. One of the easiest things to see tonight, of course, is the moon. Now, the moon's not on our map because the moon moves so quickly. But not too far away from the moon tonight is actually Mars. And you'll find Mars here in not quite the exact center of our map, but closer to the middle than the horizon here. And you'll notice that here in January, Mars is kind of over here in the constellation of Pisces, the fish. But because Mars and Earth are actually moving in slightly different speeds in our solar system, and we are actually now passing Mars by because we're on an inner lap of the solar system, if you will, we're close to the sun. We're lapping Mars in the moment. And so Mars is actually going to have quite a bit of motion over the next few weeks into February. And by then, Mars will actually have moved over into Taurus, the bull here. So you can see the bull's horns kind of coming up here, that bright star Aldebaran as the bull's eye, and it'll be just below the Pleiades. So if you're tracking Mars the next few weeks, you will definitely see a lot of motion in that planet across the sky in our constellations. Okay, but we are also going to look at a few questions. We can absolutely talk about constellations, but we have a few cool things to see through our telescopes tonight as well. So if you have any questions specifically about constellations, send them in. We'll get to as many as we can in the Q&A box and talking here while we're looking at our star map. But Jupiter and Saturn right now, this is a question coming in from Cliff. Jupiter and Saturn are not in our sky, our evening sky right now. They were very, very close together in December, but they've moved apart, just like Earth is lapping Mars because we're closer to the sun than Mars is. Jupiter is closer to the sun than Saturn, and so Jupiter has now lapped Saturn. So they're no longer as close together as they were in that picture I just showed you or during the conjunction last month. But let's see. How are you doing up on the roof there, Tad? Let's see if he has anything to show us because we have a really nice, gorgeous moon out tonight. As we were setting up the scopes, there was some nice craters and some detail right around the terminator. So as Tad joins us, let's take a look at what we should expect. Real color, true or false? This is a great question. Now, this question we've kind of gotten, and it leads into our moon here, is that when we're looking at these pictures, are these colors that we're going to see real, or are they assigned colors? Are they false colors? Well, it depends on what we're looking at. So we'll be showing you the moon here as soon as Tad is ready for us. But this is what we can expect to see the moon. Now, this would be the full moon here.
Hear my name?
Yes, so whenever you're ready, we'd love to see the live feed of the moon tonight.
All right, 1 second here. All right, so let's do that.
So as he's getting the moon ready here for us, we are seeing the moon here in real color because the moon is nice and close to us, that there's a lot of light reflecting off the surface of the moon. And this, as we can see on our screen, is the real moon. And we can see some really nice detail right along that line separating day from night. This is one of my favorite things to look at the moon. Is that line called the terminator. There we go. And the reason why I like to schedule these star parties around the first quarter moon is because we can now see some of those craters and those shadow details. Now, if we were to go outside and look at the moon during a full moon phase in about a week, there's so much light coming off the moon that it's almost blinding, and we lose a lot of that detail. It gets washed out in the light from the moon. And so when we're looking at the moon here, this is a real color image. We're using one of our color cameras here at the museum, and the moon really is just this kind of dark black and white color. So Tad, what do you like so much about the moon?
All right, well, there I am. Okay. So I've got multiple screens here. I never know where to look. Well, I think I love, which kind of just what you were saying. I love how much detail there is that you can basically always see whenever you're looking at the moon. And you don't need a camera and a telescope like you have. You can go with your own eyes. Binoculars are great. I know a lot of people got binoculars during the holidays. We got some here in our curiosity shop that we were selling. And we're a little out of focus here. But when you do get a chance, binoculars are really great for this, to look at the moon. Every time you see it, there's all these things to see. Like you're saying, there's all these craters across the moon. We're looking along the Terminator here. I'll drop the exposure a little bit. And the cool thing is that as you look at the moon over the course of a month, you get to see all these details change. The crater here, the craters there, the Maria there. As the Terminator sweeps across the moon, in fact, the moon is moving around the Earth as it's more and less of it is lit up by the sun from our perspective. These details all change. Sometimes you get a chance, if you're really, really good eyes, and depending on where you're looking, you can sometimes see bright spots actually inside the Terminator. These are actually mountains on that unlit side of the moon. They're mountain peaks, and they're just catching the sunlight. So you're seeing inside this dark area of the moon, which is cool. There's also areas on the moon that you can only see during certain phases, especially as we look at the Maria. There tend to be fault lines, rifts, sometimes where there are ancient lava tubes, for example. So lava flowed and they might have collapsed, or there might have been activity on the surface that caused it to move apart. And some of those areas, they only get lit up very briefly. So they're only seen, for example, maybe during the very first crescent phase when the sunlight is hitting at just the right angle, that we can make out the distinction from here on Earth. And then if you look the next day, or maybe even sometimes a few hours later, if you look at the end of the night, the feature will be gone. It'll be washed out by the sun. Still there, just washed out, so we can't see it. So there's these transient things you can see on the moon. And again, this just process, it repeats, it goes on through the month. The phases sweep across, and then it waxes, and then it starts waning. And then next, you know what, if you missed it, don't worry, because next month, it'll all come back around again.
You'll see them again, exactly.
Exactly, okay. I'm gonna go check on our other camera equipment.
Okay, we had some good questions coming about the moon. So we'll stay here if that's okay with you.
Yeah, I'll leave this up. I will stop my video.
Okay, wonderful. Well, we have some good questions coming in. Never, ever, ever apologize for asking questions. Again, they're my favorite part of the day. And if you have the question, somebody else likely has that same question as well. So never apologize for questions. And Sarah, I did say,
Sarah,
go for it, yes.
If you do need me to zoom in a little bit, just give a really loud shout out. Okay. I've got the speaker on outside, so I'll try to keep an ear out.
Okay, thanks for that. Yeah, it is a little cold out, so Tad's kind of going in and out just to stay warm here, and you can see that he's just inside our door as he's out running outside for the telescopes. But tonight's theme is all about color, and we're starting off with the moon here because it may seem black and white to you, but those are colors, and they actually tell us a lot about what the moon is. For instance, the lighter areas of the moon here are the highlands. They're more mountainy regions and are made out of a mineral or a rock that's mostly a northosite. So we have that same rock here on Earth, and it is white. It has that whitish appearance, and so it reflects a lot more of the sunlight. That's why it looks so bright here. Whereas if we look here, not the whole moon that's facing us is that same bright white from the northosite. We see a lot of those dark patches. And Tad mentioned those dark patches are called Maria. And so they are actually just dried up, essentially lava oceans. Because way back when the moon was forming, it was very molten. And so some of the craters actually, lava from inside the moon seeped up into those craters and filled in the lower lying regions of the moon. And so we see that lava, which has hardened and cooled over time, has turned into this nice dark basalt rock. And so the colors of rocks actually help us figure out what the moon is made out of. And that's really great because the last mission to the moon, Apollo 17, one of the astronauts who actually got to walk on the moon was a geologist, Harrison Schmitt. And he actually saw some color in some rocks and was wondering, I don't know what that is, but I have to go over there and scoop it up. And on Apollo 17, they actually wandered about almost up to 2 miles away from their landing site to collect some of these samples. And what he saw were these little orange glass beads. And that only happens when lava come from the inside the moon came spurting up and out and instantly cooled when it hit space, essentially, and then fell back down to the surface of the moon. So we get these little orange glass beads from the moon as well. So the colors of the moon actually tell us a whole bunch about what its history has been. And speaking of the history of the moon, we can see at some areas here, we can see the detail a little bit better up kind of in the north part of, or the top part of this image, where we see all those details of the craters. Whereas if we look in those darker areas of the Maria, we're not seeing as many craters. And that actually helps us date the age of the moon as well. Because on Earth, we have this top layer of the Earth that goes through a lot of erosion from wind and rain, glaciers over time, but the moon does not have any of that. And so once the crater is created on the moon, it's there. There's really not much else except for more incoming impacts that would help erase or erode a crater. And so we can actually date how old parts of the moon are by how many craters are there. And what we see here in these areas of the highlands, those whiter areas, we see a lot more craters. So those areas are much older than, let's say, the Maria, those darker regions, which got filled in and kind of covered up some of the pre-existing craters. And so the numbers of craters actually help us out a lot on features of the moon and how old it is and how did it come to be, because we don't fully understand that story. We're pretty sure that because the moon has rocks very similar to the Earth rocks, that the moon used to be a part of the Earth. It got a chunk of it broke off and then formed the moon and evolved into the moon we know today. But we didn't know that at first. It's studying the rocks and the different colors and how old they are and their compositions that are really helping us figure out the history of the moon and of our home planet Earth even. And so Cliff, I see another question that came in. Cliff, why do large areas of the moon have no craters? And those areas are just going to be younger than the areas that have lots of craters. And so again, how many craters are in any certain area of the moon helps us figure out how old that part of the moon is. Okay. And then one came in from Jessica, who's taken a couple pictures of the moon and noticed that some of the craters have a center raised circle. What is that? That's a great question. You can kind of see it. I'm going to try to move it over here. If you look kind of towards the terminator, let's see if I can annotate this. I don't know that I can. There is a crater that we see a big kind of dark Maria over to the far right of our screen right now. And if you go maybe 2 widths of your thumb up just a little bit, there's a crater that's a nice shadow and a central peak. And it looks like Tad's going to try to move that into the center of the screen for us. What happens for some of these craters, some of them have craters inside of craters. So older crater was there and it's quite large and a smaller crater came and hit it. But there's this one that we're staring at kind of right here in the middle of our screen here that has a raised mountain. And that's a little bit what Tad was talking about, is the force of that impact was such that not only did it impact and create the crater, that the energy kind of raised up the center of that crater to create a mountain. So there was kind of like an upwards force as well as that energy got transferred to the moon. Now, if we go a little bit up further from that crater that we see a nice central peak on, a little bit further to the top of our image here, we see a larger crater with several smaller craters in it. And again, that helps us date those craters. That large one, before it has a smaller one in the middle and one right next to it. Those are, again, when in time did these impacts happen on the moon? And so the moon, while we think it's always up there, and many of us, and I'm guilty of this too, take it for granted. And even though it goes through its cycles every month, and if you miss the first quarter this month, you can look next month, there's still a lot to it that it is, every time you look at it, it is a little bit different. Impacts do still happen. So some craters are still in the making. Most of the craters and most of the impacts in our solar system have happened. There's not that much extra very large debris floating around in outer space that would cause another large impact or large crater here on the moon. But impacts do still happen, and sometimes craters do still get created even to today. A question from Stacy and our son. They would like to know, what is inside a crater? More moon rocks. And it turns out that when impact comes and hits the moon, not only is it creating the hole or the crater on the moon, but it ejects a whole bunch of moon rocks and moon dust. We call that ejecta. And so, Tad, I'm going to briefly take over the screen here, just because to show this particular crater, We have to go to a phase of the moon that's a little bit more than just the first quarter, which we have tonight. So I'm going to go ahead and share my screen back. And so here what we're doing is we are looking at a full moon. So if we look on the left-hand side here, this is a picture of the full moon, the near side of the moon that is facing the Earth. And then on the right side of this picture here, we have a map of the moon or an image of the moon. That's the far side of the moon, the side of the moon that never faces the Earth. And you can definitely see the color differences. On the far side has a lot of those white highlands, has a lot of craters. That's an older surface. And the near side, that one that faces the Earth, has those Maria, those newer regions of the darker patches across the moon here. But if we look kind of in the southern part of the moon, kind of right down here, maybe about 6 o'clock, a little bit in from the edge of the moon there, that is the Tycho Crater. We've named him. And this happened, and it was such a large impact that if you take a look here, we see these streaks that kind of all point back to this crater. And that is because when that crater was formed, the impact, the incoming rock was transferred so much energy to the moon that it created the crater, but then it spewed out all this ejecta across the moon, and it traveled quite far. And you can see those lines kind of coming out, radiating out from that crater. The Copernicus crater, which seems a little bit older, which is a little bit more north of the Tycho crater, kind of up here in the middle of this Maria. You can see the crater there, but you can kind of see some of those ejecta lines as well, kind of radiating out from the Copernicus crater. And so a lot happens on the moon, and all that material that gets spewing out, that can help erode some of the older craters. So while there's no erosion due to rain or water or glaciers like we have on Earth, newer impacts, newer craters can eject material that would erode older craters as well. Is there a molten center on the moon? Peter wants to know this. We don't think so. We think the moon center has cooled down. It might be still kind of flowing a little bit, if you will. That might not be the best word on my part, but we don't believe it's like liquid lava anymore, or magma if it hasn't reached the surface. So we do think, because the moon is much smaller than the Earth, only about a quarter the size of the Earth, that it has cooled down, and it's not quite as liquidy on the inside. So we don't see any more kind of oozing liquid to fill in some of these more of these lower areas, creating the Maria. We don't see any active volcanoes on the moon anymore. But we are still figuring out, are there moonquakes? So there's still lots about the moon that remains a mystery. Yep. Okay, I'm going to show you a different picture here because we are talking about color. And so far, we've been able to get that really nice picture from our roof deck about color. And the ones we're staring at here are from the Lunar Reconnaissance Orbiter going around the moon here. But if we take a look at the moon in color, this is an example of false color. And in this case, we wanted to know, how tall are different areas on the moon? What is the topography of the moon? And so this is an example of when we would want to use false color with our astronomical images. What it tells us here is that the near side of the moon, on the left side of our image, is all pretty low-lying regions. That's where the Mari were able to fill in those kind of lighter blue amongst all the green. That's where we get all those Maria, that basalt. But then as we get away from the Maria, we get into the greens and yellows. We get some of those higher mountainy regions. And even on the far side, then we get into the yellows and even the reds. So those are going to be really, really tall parts of the moon, or higher altitudes of the topography. But look at the right side of the moon here, or on the far side of the moon, on the right side of our image. There is this very large and very deep impact basin on the south pole of the moon that is visible from the far side of the moon. So if you look in some of those craters, those ones get into the depths of purple in our color coding system here, way deeper, way lower than parts of the moon that are facing the Earth. And so there's still a lot about the moon we don't fully know and understand. Part of it is that when astronauts or spacecraft go to the far side of the moon, is that the moon is blocking the signal from getting to Earth. And so we can't send that signal, we can't view that side of the moon until that orbiter comes back to the near side of the moon to send the information to Earth. And so we don't have that direct view of the far side of the moon as frequently as we have of the near side of the moon. Okay, so I've talked a lot, and there's a lot of questions coming in. So I'm going to see if I can get through a few of these questions. And Tad, whenever you're ready for us, please just kind of jump back in. What are the possibilities of a crater's formation? And did an asteroid hit it to create the crater? So yeah, a lot of these craters. Oh, there you are.
Yep. I'm actually gonna get a little behind the scenes look. I'm gonna share a screen of an app because I need to focus the camera.
Go for it.
It's not gonna be a pretty view, but it'll be an interesting one.
Kind of sneak peek behind the scenes, like you said. It's still fun. So craters are made when something from outer space falls to the moon and crashes into it. So the larger the craters, that means it was either a larger object that hit it or it was coming in at a faster speed to create such a large crater here. And it could be a combination of both. And so we can see when we look at the moon and find all those craters, they come in different sizes because of the different amount of energy involved in all those different impacts. It's kind of like if you take a pebble and drop it in a sandbox versus like taking a big huge rock and dropping it in a sandbox, you're going to get different size craters. Those objects being different sizes and dropping them carry different amounts of energy. Okay, so it looks like Tad's focusing our scope for us. So we'll have a fun image here in not too long, but let's go to some more of our questions here. Margie wants to know, how many miles wide is the crater with a peak in it that we were looking at? I don't know. There are so many craters on the moon that I cannot keep all their names straight, and I cannot keep all their dimensions straight in my head. There are so many craters, but we have mapped them and we've named, I'm not going to say all of them, but I'm pretty sure we've named most of them. And so you could definitely find a map of the moon, and that data is out there. I just don't know it off the top of my head. Bella, who is 10, wants to know, what colors are moon rocks? So moon rocks are the colors we look at the moon on. That's a real color. So it's that some of them are that lighter white color. And so that's going to be a lot of anorthosites, very bright white rock. But some of them are basalts, like a lava rock. Pumice is an example of a lava rock. There's lots of different types of pumice out there, though. Basalt is another lava rock as lava cools down and hardens. And so the colors of the moon come from the colors of the rocks that make it up. And those rocks are the same ones we have here on Earth. Yep. Okay, so Chris, the Earth has a very hot core. Since the moon has volcanoes, does it also have a hot core? I don't believe the moon has any more active volcanoes. And so because the moon is smaller, it has cooled down faster than the Earth has. And so its interior is probably not nearly as molten as the interior of the Earth still is. That's why here on Earth, we still have plate tectonics. We still have volcanoes erupting here on Earth. Somebody wants to know, why did the moon never have an atmosphere? That's a really good question. And I don't know if that means the moon never had an atmosphere or because it was so small and its gravity is much less than Earth that it wasn't able to hold onto that atmosphere and the atmosphere escaped. And so that's kind of one of the things we've been looking at the moon is like, did it ever have an atmosphere? And I don't know if we've ever found evidence that it had a significant atmosphere whatsoever. But that might be something that we find in the rock record. Just like we use the rocks here on Earth to figure out what the environments of the Earth were back in time. Were they very heavy oxygenated, so lots of oxygen in the atmosphere, or were they more, less oxygen before plants helped us convert carbon dioxide to oxygen? That those records of an atmosphere and of an environment are held in rock records. So I don't know what a past atmosphere moon might have been like. But that's one thing we're trying to figure out about Mars, for instance, is what was the past of Mars like and where did its atmosphere go? Because it still has a little bit of an atmosphere, just not as much as we think it used to have. Okay, question came in from Chris. Can you see where the astronauts were with our telescopes? No. We're still looking at very large features here, so finding the flag or a footprint is not something our telescopes here on the roof deck are going to be able to pick up. Or even the ones you might have in your backyard or pair of binoculars. We're not going to be able to see that small of a detail from this far away. Let's see. Can we put a satellite around the moon? Yes, and we've done that a lot. And so that's where some of these pictures of the moon are coming from. Those are definitely where the pictures of the far side of the moon are coming from because we can't see them from Earth. Let's see here. So Nigel, why would the side of the moon facing the Earth be newer with less peaks than the back side of the moon? That's a great question. It looks like Tad's getting really good at focusing us in there. So we're almost ready to go back to Tad. But until then, I'm going to go ahead and share my screen so you can see that far side of the moon here again. So the far side of the moon is much lighter, and it doesn't have those dark Mari. It has a little one up here, but it's much lighter. And the crust, we think, for some reason, it was a lot thicker on the far side of the moon. So when an impact came, the molten lava underneath had more to get through to try to push through to fill in anything like that. And so for some reason, we don't fully understand it yet, but it's one of the reasons why we're still studying the moon, is we believe the crust on the far side of the moon was much thicker, and so that lava on the inside, of that molten magma on the inside of the moon, couldn't get through to fill in and create Mari on the far side. So on the near side, on the left hand of our image here, with a slightly thinner crust, when that impact came, that magma was able to come up through the crack and fill in those lower lying regions and harden. And so by filling in those lower lying regions, it kind of created that brand new surface. And we can tell that because there's fewer craters in the Maria. Okay. Well, we could spend all day talking about the moon, but we're halfway through our time already, and there's some other cool things about color I want to share with you tonight. But please keep sending the questions in. We'll get to as many as we possibly can here tonight. So let's go to one of my favorite objects, and I'm sure I talk about every single star party here. And I'm sure Tad will pipe in when he has a chance or a moment in the telescope set for us. But here is a real color through our telescopes with our camera of the Orion Nebula. So this is M45 is the catalog number for it. But this is the Orion Nebula, and it's in the belt of Orion. So if we go back to our star map here, Orion is kind of in the southeast corner. It's recognizable by the 3 stars in a row for a belt, 2 stars for knees, and 2 stars for shoulders. That's what you're going to see out even here from inside the Twin Cities. If you get further away from the cities and further away from light pollution, you can start to see his arms. So one of them is kind of is an arc out front. That could be his bow and arrow or his shield, depending on how you want to draw him in. And his other arm is hanging above his head way up here. So that is Orion. Now, hanging from his belt of those 3 stars is his sword. And in his sword is M42, the Great Orion Nebula. So if we go back to that picture that we took, here is that nebula in black and white. And you might be asking, why is it in black and white? Whereas if you look at it through like the Hubble Space Telescope, or the picture right behind me, that's the same nebula, you might see it in color. Well, this is so far away that if you look through a telescope with your eyes, our eyes have different sensors and different detectors inside of them. So we have rods and cones. So cones, those detectors are made for detecting color. Rods are detecting black and white and kind of motion. Now, this object, this nebula, is really far away. And so light has to travel to us. And the light that gets to our eyes through our telescopes isn't enough to start activating those color detectors, those cones. But our rods are firing, so we can pick up black and white just fine by looking through a telescope here, just with our eyes. And so through black and white, we can see a nice bright core of the nebula. That's where new stars are forming. We can start to see these wisps of gas around it. And this is a gorgeous, gorgeous stellar nursery. It's making new stars. Now, what we can do is this is what your eyes would see looking through a telescope. Now, if we put a camera up to that telescope, or a different camera than the one we took this picture with, that's when, here we use another camera up on our on one of our telescopes upstairs, is our camera can stare at this object for longer periods of time, and it's detector sensitive that it can start picking up those pieces of color. And so this here is another true color, real color image of the Orion Nebula through one of our telescopes up on the roof deck. And it can start picking up the reds and some of the blues here happening in the nebula. And the reds are going to be more of your oxygens, your hydrogens. And some of that bluish color here is going to be some more of your oxygens. So the color of something actually helps us figure out what this nebula is made out of. Tad, how you doing? How are we doing with the telescopes?
We have been better as far as telescopes go.
The cold temperatures, the equipment doesn't like the cold temperatures, just like us humans.
Yeah. So in fact, I'm having a problem with the other Canon, the Canon camera. I'm having a problem with that as well. I want to see if I can try to get that one back at least so we can see the moon.
Okay. And yes, I see an anonymous attendee. I misspoke and I have it mislabeled here on the screen. Orion is M42, M45 is the Pleiades. Thank you for correcting me. That is a typo on my part. Yeah. A nebula. That's a great thing. Can we define a nebula? This type of nebula that we're looking at right now is kind of like the birthplace of stars. It's a stellar nursery. Before stars can shine and produce their own light, they're formed inside these big, huge clouds of gas and dust, like the one we see here on the screen. And so we see kind of some of these blue and some of these red clouds of gas and dust here. Some of them look kind of dark. There's so many of them kind of in the center here. This area of clouds of gas is kind of folding over some of that core in the middle here. And so nebulas like this one, what they do is they're all this gas and dust, and then gravity will start to pull that gas and dust together. And once it starts clumping, eventually those clumps will get bigger and bigger and bigger and bigger until it gets hot enough that a star will ignite. And so nebulas like the Orion Nebula are the nurseries, are the areas where stars form, where stars first are born before they evolve into stars like our own sun. Now, there's another type of nebula out there there's some planetary nebula, which actually have nothing to do with planets, and that has to do with how a star dies. But maybe we'll get into that in a future date. The Orion Nebula here is what we can see up in our sky tonight, and is definitely gorgeous. And you can, if you were to look at it through a pair of binoculars or backyard telescope you'd see these white wispy clouds going across the sky here.
Sarah, if you're okay with it, I think I can get the moon back for you. I'm going to try to get M42 here, a live view of it. Hopefully.
Yep. Yeah, it's the temperatures. It's finally clear out tonight, and so we're excited. We got telescopes up there, but then when you get this cold out, the telescopes start to slow down, and they don't. It's all the electronics. Just like us, electronics don't like to be out in the cold for too long. Okay. So a question came in that Kira wants to know how many nebula nurseries are there. They are all over the place, and we can actually tell by. Let's take another look at the Orion Nebula here. Can I split screen share with you, Tad? Let's try that. Maybe I can't. I might have to kick you off here, Tad. So we have, here's a picture of the Orion Nebula taken by the Hubble Space Telescope. And so this is where it can stare at this nebula for a very, very long time and pick up all those different colors. And in this case, this is visible light, so light our eyes could detect. And it can pick up all those colors. But there's a lot more going on in Orion than just light that our eyes can see. So here is the constellation of Orion in visible light. We can see his 3 stars in a row for a belt, his 2 stars for knees, his 2 stars for shoulders, and that star up there for his head. The Orion Nebula is hanging off of his belt here, kind of that fuzzy little patch there in his sword. And that's what you would see from your backyard or through a pair of binoculars or a telescope. But now if we use light that our eyes can't see, humans' eyes can only see a very small part of the full spectrum of light. We're going to look at Orion in infrared light or heat. It's going to look for the heat signatures here. And when we do that with Orion, then the whole constellation lights up, lights on fire. And so this is an IR camera or a heat-seeking camera, if you will. Night vision goggles work this way too. They're looking for infrared light. And so we can see where the Orion Nebula is, where those new stars are forming. That is bright. It's glowing. It's nice and hot here in the infrared light. And then we can see that there's some more activity going on right here in Orion's belt, and actually all through the entire constellation. And so this is kind of one of the other uses we'd have for false color, because our eyes can't see infrared light. So what we do is we have detectors that can detect it, but then we can color code it based on what the detectors see. And so in this case, the areas where Orion is very hot, but not hot enough for our eyes to see, we've color-coded this bright, almost white color. And then we get that kind of brighter yellow and down kind of into this reddish color going around, which is still pretty hot, but just again, not quite as hot as the yellow or the white parts and not hot enough for us to see with our eyes. And so there's great uses for this false color in astronomy. We can learn a lot by using more than just the senses us humans have. And there are nebulas like this all over the sky. And so Orion is just my favorite, and it's one that's very prominent here in the winter sky, but there are star forming regions all over the place. And so here is what I was talking about of using more than just what our eyes can see. So in the very middle of our light spectrum, we have the rainbow. We can kind of split it up here from visible light all the way over to infrared, so kind of beyond red, if you will. And so this little tiny sliver here in the middle, that is what us humans can see. But look how much else there is out there. Ultraviolet, X-rays, gamma rays. Going beyond red, we get into microwaves and radar and radio. And so there's so much more out there to see with telescopes that are specialized in stuff that our human eyes can't see. So here is another image we took with our telescopes up here on the observation deck. This is the Crab Nebula. Again, this object is so far away that through our telescopes and our camera here, our eyes are only sensitive enough to pick up the white light. All right, it's not enough light coming in to pick up for activating our cones and the color here. This is in Taurus the Bull. It's the Crab Nebula. This is actually a different type of nebula. So we have Orion, which is behind me, and that was where new stars are being born. But in this nebula, this is actually the remains of an exploded star. So this is the evidence of a dead star. The leftovers, the star exploded and spewed all of its material, all of its star dust out into space, and it created this Crab Nebula. Now let's take a look at the same thing through a few different telescopes. So we're going to use false color, again, because this is what we could see with our eyes, our human eyes. But let's look at it at each of the areas of our spectrum. So areas that our eyes can't see. And by doing this, we see at each area from radio waves in the red up in the upper left, down and around through optical, which is in the green and lower right. That's what we see with our eyes, but here we false colored it green. All the way to the X-rays, the same type of X-rays that you'd get at the dentist or at the doctor's if you hurt your foot and you want to know if you broke your foot. And so each area of the spectrum allows us to see different details. Now, because in X-rays in the center, in this purple, we can see kind of a spinning disk and some kind of jets spewing out the sides here. But we can't see that hiding in the middle of our optical or our visible image down here in the green in the lower right. And what happens then, what we can do with all this, is by looking at each part of this nebula, this Crab Nebula, exploded star, in a different area of light. And if we stack them all together, we get a better understanding of what's happening here. So this is a combination of radio, infrared, optical, ultraviolet, and X-rays. And we can see the X-rays, which are going to be in this image, the most energetic part of this nebula, is hiding in the center there. And so we actually have a pulsar. We have the remains of that star, that dead star's core is here hiding in the center, giving off lots and lots of energy in the X-rays. And then as we get further out, into the material that was exploded away from this star, we see the reds, which were the radio waves. We see some of that green, which would be the optical. That'd be closest to that, what we could see through our telescope. And so there's definitely bonuses. And there's definitely a lot of reasons to look in other wavelengths and use false color again. And what's fun is that you guys can do this yourself. So here is our at-home activity. So if you go to this website, public.nrao, so National Radio Astronomy Observatory, .edu/color. And we'll put this link into the chat as well, so you can just click on it. But if you go to this website, what you can do is over on the left of our screen here, you could drop down into different objects. In this case, we have M1, the Crab Nebula selected. And then you can choose how you want to false color your nebula. If you want to use radio waves, you could turn it on or off, and you could sign radio red, or you could sign a different color. And so you can create your own false color deep space object here This is all real scientific data collected by these telescopes, but you could stack your own image and create your own screen for maybe it's a wallpaper or maybe it's a screensaver. So you can create your own deep space image using false color in those areas that our eyes can't see, and you can color code it to your liking. And so it's kind of a fun at-home activity of what we just did on screen. Oh, okay. Some of these questions came in are my favorites. Bruce wants to know, why does hydrogen and oxygen create different wavelengths in different colors? Oh man, let's go back to the Orion Nebula here from Hubble. There we go. So here we have the Orion Nebula, all these different colors. Now, the different colors tell us what the atoms are, what material it's made out of. And when we look at it through like the rainbow of light, only oxygen will have its one pattern of light. But then hydrogen will have a different pattern of light. It's like a fingerprint. No two elements, of our periodic table, no two materials, oxygen or calcium or hydrogen or helium, they each have their own fingerprints that is their own specific rainbows of light. Now, we can use a diffraction grating to do this. Now, I'm going to see if I can pass, Tad, are you there? Maybe we can get a picture of the moon here as I get a quick thing to show you guys how this rainbow of light from each material actually gets split and how we can tell what they're made out of. But I'm not quite sure if Tad's ready for us yet. So if he is, we'll go over to that. So in the meantime, Michael wants to know how many stars are in the whole wide universe. That is a trick. That's a tough question. You want to jump in there, Tad?
Did I hear my name?
If you're ready for us, we'd love to see another view through a telescope up on the deck.
I'm afraid all I've still got is the moon.
Okay, let's take a look at that.
Okay.
Okay, so as Tad's switching us over to the moon, I'm going to grab something that'll help us figure out how the different materials of stars, we can tell them apart. And then Tad, in that time, do you want to answer the question of how many stars are in our universe?
Oh, an easy one. Okay. Well, we can do some math, I suppose. How many stars in the universe? That's a big question. Well, we estimate there's something like 400 billion stars in our galaxy, average. And so I'm realizing what a mess my hair is here. Hat hair, great. 400 billion stars in our galaxy. And we think our galaxy is probably pretty average. Our Milky Way galaxy is probably pretty average. There's definitely smaller galaxies. There's bigger galaxies. We found galaxies with maybe upwards of 1 trillion stars in them. But let's take our galaxy's average, 400 billion. And then based on estimates of what we can see within our visible universe, we think there's something like 2 trillion galaxies. So if we assume just on average that every galaxy has 400 billion stars, and there's 2 trillion galaxies, then all you need to do is multiply 200 billion by 2 trillion. And there you go. That's how many stars are in the universe. What that is off the top of my head, well, 800 billion trillion, right?
Lots and lots of zeros.
Lots and lots of zeros. I was trying to do the SI, the
powers of 10, yep.
But that wasn't going to happen. So,
lots and lots of zeros.
Yeah.
Okay.
Okay.
So I'm going to jump back in here because I grabbed, it's a pair of glass that we have. It has diffraction gratings and they're kind of like rainbow glasses. Have you ever seen them before? Now I'm going to hold this up to my camera and you should see kind of rainbows go in front of my face then. So if you can see that, what's happening and why I look kind of goofy here is because the light is getting separated up into its individual rainbow. Now, if I shine a light on this, let's say my phone flashlight, you can see all the rainbows there. And what happens is this light, and this kind of gets into a question here of, is there color even if it's not activating our cones? Is this color, these rainbows, are there even if there's nobody to detect it? So kind of that kind of adage of, if a tree falls in the woods but nobody's there to hear it, does it make a sound? In this case, yes. If something is giving off light and there's nobody there to see the light or the color of it, the color is still there. And it all has to do with what wavelengths or how much energy does that thing have to give off. And just like my phone flashlight here produces a rainbow of colors, you can kind of see red all the way through blue. I'm hoping, maybe Tad's taking over my screen. Maybe I should go back and do full screen here. Tad, I'm going to stop sharing the moon here. So if we go back and we see full screen, try to get full screen here and see all of those rainbows created by the LED that was my phone screen. Different types of gases will have their own independent rainbows. Some might be missing red, some might be missing blue or green. And that's how we tell what colors stars are, what material stars are made of, or the nebula behind me, how I know kind of the reds are more of the hydrogen, the blues are a little bit more of the oxygens, is because they each have their own fingerprint of light and their pattern, their own pattern of the rainbow, that no two elements are ever the same. Okay. Are nebulas seen in different countries? For example, let's say Canada. Yes, because we're all one Earth, that anywhere here in Minnesota, you can see the Orion Nebula. If you go north of us, you can still see Orion Nebula. Orion is a constellation that is found anywhere between the North Pole and, I think you can still see all the way up to the North Pole. Most of the northern hemisphere and some of it down below the equator a little bit. And probably not all the way down to the South Pole, but a large chunk of the Earth can still see the Orion Nebula. And it's going to look the same color, the same type of shape, no matter where on the Earth you are. It really all just depends on your latitude if you can see it. Absolutely. And then there's plenty of other nebulas like the Crab Nebula we just saw. Absolutely. It's one Earth, one sky. What would happen if we lit a match in space? Well, most of space is a vacuum and fire needs oxygen to burn. While there is oxygen in the Orion Nebula, it is not going to be dense enough. It's not going to have enough in any one particular area for it to probably actually burn in space. So you need an oxygen-rich environment for a flame or a match to burn in space. Okay. Do newborn stars move away from nebulas? Yes. For instance, our sun, we are no longer in the sun's kind of birth nebula, if you will. And so stars over time, like the Pleiades, which are another one of my favorites, those are in Taurus the Bull. Over time, those stars will kind of drift away from their parent nebula. And as a nebula makes new stars, the nebula will actually thin out as well because its material has been going into making of new stars. Okay, could star shapes change throughout decades? And could it be a dog or an ice cream cone or a crab? This probably gets, I think this question from Emmy comes back to our constellation shapes. Our constellations that we drew in the sky are human creations. We decided which dots to connect together to make whichever shapes in the sky. So that's totally up to you and your imagination. Now, stars in space, they're actually just spheres. And so they're going to have gravity pulling in on them, and they're going to have their own temperature and pressure pushing out on them to kind of balance so it doesn't collapse and doesn't, explode until it runs out of fuel, and then it'll do one or the other or both. And so stars don't really change shape. They're going to be spheres out in space. Once they die, then it gets complex, and maybe their magnetic fields might make them slightly less spherical. How old are nebulas? It depends on when the star died. If we're talking about something like the Crab Nebula, which a star exploded, that nebula would date back to when the star exploded. Or in cases like the Orion Nebula, where stars are just being born, I don't know if there's a way to date them other than the stars that they've made. So they'd have to be older than its oldest star in it. But I guess I don't know how old, particularly either the Crab or Orion is. I think the Crab dates back. The Chinese have really good records. I think they dated back into like 1500s. I want to say, maybe even older than that. Okay. There's so much to see and so much to talk about. And I sometimes wish that we had more than an hour tonight to do all that. But that's always why we have more cool stuff coming up. So we talked about color tonight and different ways to use it. Real color to see the moon and Orion and figure out what things are made out of, but also false color like this here to show us things that our eyes can't see in different areas of the spectrum. But we're going to have a whole weekend dedicated to outer space stuff. It is Space Fest 2021, and it's coming up February 4th through the 6th. And lucky for all of us, it is virtual still. And so we have lots of good stuff planned. And if you want to know what exactly is happening here, there's a trivia night that's happening that Tad was involved in. I'm really looking forward to that. Take a look at our website here. We'll paste that into the chat. But that is z.umn.edu/Spacefest 2021. And kicking off Space Fest on Thursday night, February 4th, is a book talk with the author of The Sirens of Mars. And so this is going to kick off Space Fest weekend, where you dive deeper into topics all about outer space. And speaking of Mars, we didn't talk about it tonight, even though I did show it to you on our map tonight, because next month on our February Star Party, we're having a special guest speaker, Derek Demeter from Seminole State Emily Buehler Planetarium down in Florida. Now, he is a colleague of Tad's and I's, and he has lots of experience with star parties. But even cooler than that, I think, is that he actually got to attend the launch of the Perseverance rover. And so our next star party is February 19th, the day after the Perseverance rover lands on Mars. And so there's lots of cool things coming up here in the next few weeks, and we got to go dive deeper into each of these topics, and we'd love for you to join us. And what's wonderful about all this is that we have wonderful donors like Ruth and John Huss that made this program possible. And any gifts of any size definitely help us do some of these really cool online programs so we can talk to you every month, even though our doors for the moment are closed to keep us all safe and healthy. So those are some cool things I want to talk to you about. Make sure you know about. We have a few minutes left here to keep going into some of your questions. And at any point in time, Tad, if you want to reshare that moon screen, go for it. I'd love to see some more live shots before you run out of time tonight, before the equipment gets too cold and completely stops working. Okay, so a question came in. Will a telescope camera be able to stack images that are colored like the ones we are showing? Yes. So you can buy different telescope or different cameras to put on the back of a telescope or a pair of binoculars or anything like that. Some cameras have color sensors. So that'd be a color camera. Some of them are just black and white, so it picks up all the different light coming through. What you can do is you can also put filters. Let's say I only want to look for red lights, and you put a filter there. And then maybe you only want to look for blue lights, so then you put another filter. And so then what you can do is after you take all those individual images, you can stack them to create a full color image, much like that Hubble Space Telescope image, or how we combined all those images from the Crab Nebula from radio all the way up through X-rays and stacked them that way. Absolutely, cameras can do that. It just takes more processing on the back end. So you wouldn't get a live shot like Tad is showing us here of our moon. Which zodiacs have nebulas, even if they do? No, I don't remember off the top of my head. A lot of them do. Now, some of them will have planetary nebulas or a nebula much like the Crab Nebula, which is leftovers of star. But each of our 13 zodiac constellations have some really cool deep space objects in them. So check out our Constellation Hunter video series. We mentioned a few of those in that. But you can also definitely take a look online because there's way more deep space objects than we could ever possibly talk about in a night or in a cool video online. Let's see. Daniel wants to know, what size telescopes do you need to see the nebula? For the Orion Nebula that we saw tonight, you really just need a pair of binoculars. Now, to see the detail that we showed in kind of that black and white image or the non-Hubble Space Telescope image, up on the roof deck, we have telescopes that are about 10 inches in diameter. We have one that's 9, and I think we're using a refractor as well upstairs, which might be 5 inches in diameter. But telescopes all work slightly differently, so it's not just about the diameter of a telescope and what it can see. But to see the Orion Nebula, it really looks like wispy clouds, and to get some of the basic stuff, you really just need a pair of binoculars and a nice dark sky. So get away from the cities if you're using binoculars. After a star explodes, Neil, how does it continue to send light? Yes, Great question, because stars are living when they're making their own light. But when stars stop making light, stop the process of nuclear fusion, they die. However, they can still have so much stored up energy that they're still trying to get rid of their stored up energy, that's how they can still give off light, even though they're not making any new light. So that's how white dwarfs or neutron stars or pulsars are still giving off light, even though they're not making any new light, is they have so much stored up that they're still trying to just get rid of it. Yep. Okay, so I think we have time for maybe 1 or 2 more questions. Kira, what can't the Hubble Space Telescope see? The Space Telescope is an awesome telescope. It's 30 years old, and it is made to see in the visible and a little bit into the infrared, a little bit into the heat, I believe, and a little bit into the ultraviolet range. So the Hubble Space Telescope cannot see radio waves. It cannot see microwaves or X-rays. It was only made to look mostly in that area that our human eyes can see, with a little bit extra that our human eyes can't see. We're building the James Webb Space Telescope, and that will see some different stuff than Hubble can see. And we're hoping, fingers crossed, that the James Webb will launch later this year. Don't mark my words, because it was supposed to launch in 2018, and it's such a big project that it's been delayed a little bit every year. But we're hoping this year is the year that it'll actually get launched. Okay, I think we only have time for one more. So how can you be caught up on these events and more? Great question. They're all on our website. We record all of our programs here. So if you missed last month's, or if you want to come and watch tonight's again, for instance, for that at-home activity, we have recordings of them all on our YouTube channel as well. But all our events like Space Fest coming up, and the book talk and the trivia night, and next month's Star Party that we're talking about Mars and the Perseverance rover with our special guest who actually was there at the launch, that's all on our website. So please join us. We are so happy to see you guys here virtually, and we can't wait to see you back in person. Okay, we're going to hang on here. We have a few last questions, but I'm going to sign off. We'll try to get to as many questions as we can typed back in the Q&A box there. But have a wonderful night, everybody. Thank you so much for joining us. It's a clear night, but it's really, really cold out. But go look at the moon yourself. It's definitely worth it. Bye.